Hello student, I am Professor J.D. Gowli, KK College of Agricultural Engineering and Technology, Nasik. Today we will discuss about the experiment of ultimate analysis. Then let us see introduction. A fossil fuel, coal, forms when dead plant matter is converted into peat, which is converted into lignite, then sub-bituminous coal, then bituminous coal, and lastly anthracite. This involves biological and geological processes that take place over a long period of a time. Heat and pressure act on it to finally convert it into coal. Then ultimate analysis, we determine the coal is composed primarily of carbon along with variable quantities of other elements, chiefly as hydrogen, sulfur, oxygen, nitrogen. Then ultimate analysis is also known as elemental analysis. It is the method of to determine the carbon, hydrogen, nitrogen, sulfur and oxygen content present into solid fuel. Okay. Then what are the need for analysis? It is essential to understand the properties of biomass material to evaluate their utility as chemical feedstock and also design suitable gasified system. The analysis is carried out to the find of the oxygen required for combustion for efficient production of energy. There are different types of two types, proximate analysis and ultimate analysis. Proximate analysis is to determine moisture content, volatile matter, ash content and fixed carbon content of a fuel. It is reported as dry weight. Okay, then determination of carbon and hydrogen. Okay, this is the equipment of determination of carbon, hydrogen. Okay, about 0.20 gram accurately weighted coal is burned in oxygen in apparatus shown above. Carbon is converted into carbon dioxide and hydrogen is converted into hydrogen. Okay, H2O, that is KOH and CaCl2 absorb carbon dioxide and hydrogen respectively. It increases in weight of the tubes are noted. Then percentage of carbon. How we calculated the percentage of carbon? This is the formula of percentage of carbon increase in weight of KOH tube into 12 into 100 divided by weight of the coal sample taken into 44. Then percentage of hydrogen. It is increase in weight of CaCl2 tube into 2 into 100 divided by weight of coal sample taken into 18. Then determination of nitrogen. This is the equipment of Jaldal flask. Okay, this is the glassware of Jaldal flask. This is the Jaldal flask. Okay, this is the beaker. This is the digestion heating Jaldal flask. Okay, this is the stand. Then how to procedure of the determination of nitrogen content. First, 1 gram of accurately weighted powder coal is heated with H2SO4 in Jaldal flask. It is treated with excess KOH. Okay, then liberated ammonia is distilled over and absorbed in a known volume of standard solution of acid. Then unused acid is determined by back titration with standard NaOH. Then how we calculated the percentage of nitrogen. This is the formula of percentage of nitrogen volume of acid used into normality into 1.4 divided by weight of sample taken. Okay, then determination of sulfur content. Sulfur is converted into sulfate. The washing are treated with BaCl2. Okay, then BaSO4 is precipitated. Precipitated is filtered and washed and heated to constant bed. Then we calculated the percentage of sulfur. Formula is the weight of BaSO4 obtained into 32 into 100 divided by 233 into weight of coal sample taken. Then determination of ash and oxygen content. Coal sample of accurate weight in a crucible is heated in muffle furnace at 700 plus 50 degree plus or minus 50 degree Celsius for half an hour. Crucible taken out on and cooled first in air and then in desiccator and wetted. Then how we calculated the ash content? Percentage of ash content is equal to weight of ash left into 100 divided by weight of coal taken. Then percentage of oxygen is 100 minus percentage of in bracket O plus H plus S plus N plus ash content. Okay, that is the O means oxygen plus H means hydrogen plus sulfur plus nitrogen plus hydrogen. Okay, then this is the pit content. Carbon percentage is the 55 to 60, then hydrogen percentage is the 6 to 65, then oxygen is the 30 to 35, nitrogen is the 1.5 to 2, then sulfur 0.6 to 1. Then lignite content. Carbon percentage is the 70 to 75, then hydrogen is the 4.6 to 5.5, then oxygen is the 22 to 26, then nitrogen is the 0.6 to 1.0, and sulfur content is 0.6 to 1.5. Then bituminous. Carbon is the 80%, then hydrogen is the 6%, and oxygen is the 50%. Then anthracite. Anthracite is the first one is the carbon content present in anthracite is the 93%, then hydrogen is the 4 and oxygen is also 3. Then total carbon content. Fixed carbon plus carbon present in volatile matter, it is the high total carbon represent as high calorific value of the fuel. Okay, then hydrogen, it increases the calorific value. H2 remains as a coke oven gas. It is associated with volatile matter of coal. Pit bituminous content 4.5 to 6% hydrogen. Okay, then anthracite contains only 1 to 2%. Then nitrogen, present up to 1 to 3% of nitrogen. It comes from protein as matter in vegetable matter. Then inert nitrogen decreases calorific value as a coal mature extractable nitrogen decreases. Its proportion does not depend on rank. It varies from 1 to 2% in all. Then sulfur content. Okay, sulfur content, it increases the calorific value but undesirable. Its oxidation product in presence of moisture cause corrosion of equipment and pollution. When used in steel making, it badly affects properties of iron and steel. The sulfur exists in three forms, that is pyritic, organic and sulfate. World coal contains 1 to 3% of sulfur. Okay, then oxygen content. Less the oxygen, better is the coal. Decreases from lignite to anthracite. Then As oxygen content increases, moisture holding capacity increases and caking power decreases. Then phosphorus content. It is the undesirable in metallurgical as it badly affects properties of metal. Then Indian coking coals have less than 0.15% phosphorus. Then this is the chart of ultimate analysis constituent of coal. Peat content percentage of carbon is the 23, then percentage of hydrogen is the 10, and percentage of oxygen is the 59, percentage of nitrogen is the 1.5, and percentage of sulfur is the 0.5, then percentage of ash content is 6. Same as lignite is the percentage of carbon, percentage of hydrogen, and percentage of oxygen is the 42, 7, and 43. A percentage of nitrogen and percentage of sulfur is also same. In lignite is the 1, and percentage of ash content is also 6. Then bituminous is the percentage of carbon is 77, then percentage of hydrogen in bituminous is 5, then percentage of oxygen is bituminous in 5%, then percentage of nitrogen is the 1.5, then percentage of sulfur in bituminous is 0.5, then percentage of ash content in bituminous is 11%. Okay, then next one is the subbituminous is the percentage of carbon in 59 is 59%, then percentage of hydrogen is subbituminous is 6, then percentage of oxygen is 29.5, then percentage of nitrogen is the 1, then percentage of sulfur is the 0.5, then percentage of ash content is 4. Okay, then semi anthracite. In semi anthracite, percentage of carbon is 80%, then percentage of hydrogen is the 3.5%, then percentage of oxygen is the 4.5%, then percentage of nitrogen is the 1.5%, then percentage of sulfur is the 0.5%, then percentage of ash content in semi anthracite is the 10%. Then next one is the anthracite. Anthracite content percentage of carbon is the 86.5%, percentage of hydrogen is the 2.5%, then percentage of oxygen is also 3%, percentage of nitrogen and percentage of sulfur is the 0.5 and 0.5%, then percentage of ash content in anthracite is the 7%. Okay, thank you.